In this lesson, we learned how to find the missing side using trigonometry. So here's the situation. If we have a triangle and we know it's a right triangle, that's important. Trigonometry that we're using is all about right triangles. And let's say we know this is a 40-degree angle and we want to find this missing side over here. And let's say we know the hypotenuse. Maybe we're building a roof or something like that. There's a little house kind of thing. And we're looking for x, and we know that maybe this is 15. Well, we can use our sine, cosine, and tangent to find that missing side. And here's the key. The key is this, the steps that is that we can find the measure, or when we're given the measure of an acute angle, so one of the two acute angles, and a side of the right triangle, we can find the other sides by doing these steps. Step 1, we need to decide how the side you know and the side you need relate to the angle. Are they opposite, adjacent, or the hypotenuse? Then we need to write a trigonometric equation, and that would be one of these. We might say sine of our angle is opposite over hypotenuse. Cosine of our angle is adjacent over hypotenuse. And tangent of our angle is opposite over adjacent. Okay? So we're going to use one of those three equations. Then we're going to use our calculator to evaluate the trig ratio. So your calculator knows what the sine of 40 is, or the cosine of 40, or whatever you need. And then we're going to, after we plug in these numbers and use our calculator, we're going to solve it just using algebra. So for example, here on our little triangle over here, let's go through those steps here. So first step, we need to decide how are these related to the angle. So again, you can think of it like this is our angle A. You're standing over here, you're looking across this field. Here's the two legs. Which leg is this? Is this the leg that's adjacent and connected? No, this is the opposite to the 40-degree angle that we know. And what is this 15 side? Well, that's the hypotenuse, because it's opposite the right angle. So, opposite and hypotenuse, which one of our three ratios here uses opposite and hypotenuse? Well, opposite and hypotenuse is not tangent, that's opposite and adjacent. But opposite and over hypotenuse is sine. So we're going to use sine is what we need. So we got sine of our angle, 40 degrees, equals the opposite, which we don't know, over the hypotenuse, which we do know. And that's how we set it up. Now we need to know what the sine of 40 is. Well, we can go to our calculator, and we can go, you'll see you have sine, cosine, and tangent keys here like this. And so click on the sine ratio, and we want to type in 40. Now you do need to make sure that this is in the right mode. All right, whoops, 40, there it is. So make sure it's in this degree mode. Now whatever calculator you are, there's different ways to change it. But it should tell you somewhere in your screen what kind of mode you're in. We don't want to be rad, that's called a radian. But in degrees, we take the sine of 40 degrees, and that is 0.64278. We're going to cut it off right here. So we want to round this 7 up to an 8, because this is bigger than 5. So 6427. Nope, 6428, that's what you say. So the sine of 40 is 0.6428. And we know that is equal to x over 15. Well, now notice in our equation that we rewrote, we don't have any sine or cosine or anything weird like that. It's just a proportion. In fact, you can put it over 1, and now we can see the proportion. And so we have 0.6428 times 15, cross multiplying here, equals x times 1, which is just x. And we can see what that gives us. So we've got that number in our calculator there. And we're going to multiply that number times. If we hit the answer key, if you're on this Desmos calculator, you can use that answer to get that blue thing. times 15 there. And it looks like we got 9.6, all right? One thing to notice, by the way, when you're writing down these trig ratios, use that to 4 decimal places. When you're writing your final answer, usually it says, this is just an example, but watch out for your rounding. So this is 9.6 is our answer there, and that leaves us with x, all right? So x is 9.6 feet or whatever it may be. All right, so that's how that works there, okay? So we see we got these trig equations. We can use them to find missing sides, and we can also find out some different equations using trigonometry that we call identities. So we saw a little bit of that here. So an identity is an algebraic equation that is true for all replacements of the variable. So plug in any number and that'll be true. So when working with trig ratios, this happens quite a bit, all right? So we've seen a couple. One we've seen is that the sine of an angle is equal to the cosine of 90 minus that angle, okay? So in other words, if we look at our triangle here, here's a triangle, there's 3, 4, 5, okay? Call this angle A. The sine of angle A is 3/5, and whatever the measure of angle A is, this angle is 90 minus that. So we can say the cosine of B is also 3/5, and the reason is because this is opposite of A, but it's also adjacent to B. So the opposite of one is the adjacent to the other. All right? So that's an identity. That's something that is always true there. Okay? Well, let's see. We've got one more here. We could say this. We could say that the tangent of an angle is opposite, we know it's opposite over adjacent. It is the sine of the angle over the cosine of the angle. All right. Well, how is that true? Well, we know that tangent of theta is, let's just write it out, opposite over hypotenuse divided by the cosine, which is adjacent over the hypotenuse. And if we were to multiply this by that, whatever the hypotenuse is, on top and bottom, you can do that with fractions. Then we can see that it's just the opposite over the adjacent. And that kind of proves that this thing here is very true. The tangent of an angle, so that's the Greek letter theta, by the way. So this is theta, this is an angle. Okay, so the tangent of an angle is the sine the angle of A over A. We should make this the same. Let's do that. It's okay. The sine of A. All right, so I'll fill that back in there. The tangent of A is the sine of A over cosine. So we don't need theta in there. Just A. Okay. Sometimes you'll see theta. We'll use that a little bit, but we're talking about some angle A. So we got these angles that add up to 90. They are complementary angles, all right? Two angles that measures that add up to 90. All right, well, let's practice a little bit here. Let's find some missing sides here. So if you want to pause it, you can try that out with us. Let's see what we got. So here we've got this angle 32 that we know. And let's identify the sides. This is the opposite leg, this X over here. This is the adjacent leg. And this longest one is the hypotenuse, that is Y right now. So let's start out with X. How does the X relate to the 32? Well, it's opposite. And we know the adjacent. So which one, sine, cosine, and tangent, uses opposite and adjacent? One way, by the way, to remember which one, sine, cosine, and tangent, is an acronym we like to call SOHCAHTOA. This helps us because we know that the sine is the opposite over the hypotenuse, cosine is the adjacent over hypotenuse, tangent is the opposite over adjacent. So we got opposite, and we Know the adjacent. Well, which one's opposite and adjacent? That's tangent. So we need a tangent equation. So the tangent of our angle, 32 degrees, is the opposite length, which we know is x. We actually don't know it, I guess. And the adjacent is 4. There you have it. So we can go to our calculator. We can find out what the tangent of 32 is. Let's go find that out. All right. And so we'll get our tangent of 32. Looks like 0.6249. We'll round that off to 49 because we're cutting off this 6. So 6249. Okay, so we got 0.6249 equals x over 4. Okay, and now we can cross multiply that, or if you want to think of it, we can just multiply both sides by 1. Okay, so if you want to, or I'm sorry, by 4, multiply by 4. Okay, or think of it as cross multiplying. That works good too. Any way around it, we've got 6249 times 4 equals x as we multiply that. So let's go to our calculator and hit, make that times 4. So there it is. We're going to round this off. Usually we'll round the final answer off to 1 decimal place. So let's round that off to 2.5. All right, so really all that's going on there, by the way, is when we ask the calculator what the tangent of 32 is, it's telling us that whenever you have a triangle, a right triangle, with a 32-degree angle here, the ratio of the opposite leg over the adjacent leg is 62% about. In other words, this leg is 62% as long as this leg. That's always going to be true if you have a 32-degree angle here. So that's what we're using. Now, notice that the tangent is just a decimal number here. Well, your calculator kind of has all those numbers memorized, but once you're comfortable with the fact that the tangent of 32 is just a decimal number, you can go ahead and just leave it alone for right now and multiply it up and say, well, 4 times whatever the tangent of 32 is what x is going to be. And then we can go over here to our calculator and we can just type in 4 tan 32. Let's see what happens here. So what we did is we kind of did this in 2 steps, but if we say 4 tan 32, notice this, it's the same thing. Because this decimal number is 4 tan 32. I'm sorry, it's tangent of 32 times 4. So we don't necessarily need that number there. And so once we're comfortable with that fact, then we can leave it as tan 32, multiply it up, and we'll get our answer of 2.5. Same thing. Great. Well, what about y? Now this gets a little more challenging here. Okay. So we want y, and y is the hypotenuse. And we know, now we do know this, but I would recommend avoiding reusing numbers if we can avoid it. So let's use the 4, which is the adjacent, and the hypotenuse, which is y. And which one uses adjacent and hypotenuse? Well, that is cosine. So cosine is the adjacent over the hypotenuse. So we have cosine of 32 equals the adjacent, which is 4, over the hypotenuse, which is y. Now this one's a little more challenging because the y is on the bottom. Okay, well we can go get the cosine of 32. Let's go get that there. Cosine of 32. We'll go and clear this up here. And then we'll say the cosine of 32. And that's going to give us 84880. So we want to write this down, by the way. If you write this decimal down, you can write it down to 4 decimal places. Okay, we don't round it off too far too early. Well, how do we do this? Well, notice we can make it into a proportion. We know how to solve proportions. We cross multiply, right? So we have 0.8480 times y equals 1 times 4, which is 4. Now what do we do to solve this? Well, we're going to divide. So we'll divide by that decimal number, 8480. It's an extra step here, 8480. And so we're going to go take 4 divided by that decimal number. So we'll go back to our calculator here. And we've got 4 divided by, and you'll have an answer key on your calculator. So on Desmos, it's this ANS means answer down here. So if we divide that up, we got 4.7. Okay. Now, by the way, while we're looking at this, we could say this is 4 divided by cosine 32. Notice it's the same thing. Okay. So if you want to just keep it as cosine 32 until the end, that's fine. 4.7 is the number. So let's go jot that down, and we're done. Y equals 4.7. Okay. All right, that's super handy there. So we'll leave it at that. I hope that makes sense there. So we can see how this powerful tool of trigonometry can help us to find a missing side by deciding which ratio we need, or first of all, how the sides relate to the angle. Then we're going to find the ratio or the equation that we need, plug in the numbers and use the calculator to find that trig ratio, and then solve the equation.